Hello, good afternoon, everyone. Welcome to the YouTube channel of Chem Academy. Good afternoon, Priyanka. Sir, नहीं मैम है यहाँ पर. Good afternoon, everyone. Good afternoon, Priyanka, Archana, Asha, Keshav, Ananya. Dictator, ma'am, I'm preparing for JEE Advanced. Can I attend this lecture? Yes, of course you can. Of course you can attend today's lecture. Hi, it's okay, Priyanka. I was just joking with you. Okay, so if you haven't subscribed to our channel yet, quickly subscribe to our channel. Okay, like this video and share it with your friends, and then we're going to start with today's session. Okay, so the last class that I took for organometallics, we did previous year questions in that session. In the last class, we did some previous year questions, and when I was teaching you those questions, some of you had requested me to help you solve more questions related to the stability of compounds. So that is exactly what today's session is going to be about. I'm going to come up with some examples related to 18 electron rule. All right. And then we will determine the stability of compounds. So let us begin with today's session. The topic for today is organometallics. Organometallics. This is the lecture 2. Just a second. I think the pen is not working fine. This is the lecture 2 for organometallics, and today we are going to be discussing some questions specifically relating to the stability of compounds. Okay, so we know that we use, you must have heard, I'm going to give a brief overview before we get to actually solving the questions. I'm sure that you all must have heard of EAN rule, which is known as the effective atomic number. Okay, it is known as the effective atomic number. My pen is glitching today. Okay. Effective atomic number. But this method of determining the stability of compounds is actually not very useful. Okay, effective atomic number method for determining the stability of a given compound is generally not used. Okay, it is generally not used, and neither it is effective. I'll tell you the reason why it is not used and why is it not effective. Because in effective atomic number, we will have to use, to calculate the valence electron count, we will have to use the atomic number of the given element. But atomic numbers are very hard to memorize. Okay, suppose if you've been given a particular element which is a very high atomic number, obviously you will not be given the periodic table in the exam, right? And obviously it is very tough to memorize the entire periodic table. So since this method involves the usage of atomic number, therefore it is not very effective, and we keep away from using this method. All right. Junaid बोल रहे हैं, what is 𝗧cie? Junaid, we will come to 𝗧cie. I have questions related to 𝗧cie in today's session. You just keep watching. Adarsh Singhri is asking me, ma'am, आपका video is enough for NEET or not, ma'am? Please tell me. Okay, Adarsh, the organometallics that is being taught on Chem Academy's YouTube is more than enough for NEET. All right, it is more than enough for NEET. The questions that we discuss here are actually the IIT JAM level questions. So these are going to be more than enough for NEET. PK 45 abhi questions karenge. We will get to the questions. Right now, I'm just giving you a brief summary of the theory. Uske baad we are going to get to the questions. Yes, Keshav, we will be discussing previous year questions for JAM, but the ones who are here for JEE and NEET can also do these questions. These are going to be helpful for them as well. Asha Chaudhary, good afternoon. Good afternoon. Okay, so right now I told you why do we not use the effective atomic number. Then what do we use? We use what is more effective and what is a better way of identifying the stability of compounds is the 18 electron rule. All right, it is the 18 electron rule. Now, what exactly is the 18 electron rule and what do we do in this? We figure out the valence electron count. All right, we figure out the valence electron count. Valence electron count. We determine the valence electron count. We can also write it as VEC. And what is going to be the formula here? It will be the group number of the metal ion. The group number of the metal plus the contribution of the ligand which will be involved. Contribution of the ligand and plus minus charge on sphere. Plus minus charge on sphere. I am just going to explain what does this plus minus mean. Now this is actually the formula for determining the valence electron count in case of 18 electron rule. Now this plus minus charge on sphere is written for a reason. If the charge, suppose this is the sphere, and suppose here is some charge. So while determining the valence electron count, if the charge is positive, then we will take in valence electron count as negative, and if the charge is negative, then we will take while determining the valence electron count as positive. I know you might get a little confused over here, but let us do a few questions and you will know exactly what I mean. Questions करके आपको बिल्कुल समझ में आ जाएगा कि मैं क्या बोल रही हूँ. Okay, let's just get to the questions. I hope सबको clear हो रहा है, कोई दिक्कत नहीं होनी चाहिए. मैंने बस एक brief summary दी थी for you to be able to solve the questions with me better. Now we will get to the questions. Now look at here, this is the very first question for today. Now if we have to determine whether this compound is stable or not. Stable or not. Okay, we will determine whether this satisfies the 18 electron rule. Okay, whether it satisfies the 18 electron rule or it doesn't. If it is going to satisfy the 18 electron rule, then it will be stable, otherwise it will not. How can we determine that? We will find out the valence electron count for this. How do we do the okay? So before we actually get to finding the valence electron count, one very important thing I would like to discuss with you. So I will also discuss one more thing, which is the metal-based electron count. Metal-based electron count. Now, this is something that you will have to memorize. You will have to memorize this, and it is going to help you solve a lot of questions, and it is going to be needed everywhere in questions related to determining the stability of compound via 18 electron rule. So how do we do it? Let us write down the group numbers first. These are the group numbers. And 12. And these are going to be the series. First of all, I will write Okay, there was some glitch. Now, how can you do it? See, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. This is the 3D series. Now, the 4D series. Here it is going to be yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, and cadmium. And for the 5D series, it is going to be lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold, and mercury. So these are the group numbers. These are the group numbers which you need to memorize for you to be able to solve the questions related to the 18 electron rule. You just make some mnemonics to memorize this and you will be able to easily memorize these. All right. 𝐂𝐸, previous year questions were done in lecture 1 of organometallics. Then some of you asked me to discuss more questions related to the 18 electron rule because they were facing problems in that. So I have specially arranged lecture 2 to solve the questions related to the 18 electron rule. This was just a brief summary which we will need to solve the questions that are just going to come. If you want to do specifically the previous year questions, please go ahead and watch lecture 1 of organometallics in Chem English that I took some days ago. All right. Now, I hope it is clear. So this is something that you need to memorize and it is really going to help you in solving questions. Now, moving on to the questions. Suppose this is a question, if you have to determine its stability, how will we determine the stability? So it can, since this is K4, it can also be written as, this can also be written as Fe CN6 and 4 minus charge is going to come here. Now we have to see if it follows the 18 electron rule or it doesn't. So we know that the group number, what was the formula for VEC for calculating the valence electron count that we will find for this right now? It was the group number of metal ion plus contribution of ligand and plus minus charge on the sphere. Here, the group number of metal ion is going to be, just calculate in your head from the mnemonics. It is going to be 8 for iron plus its contribution is going to be 1 into 6 and this is negative. So this will be added. The signs are reversed. Now let's just calculate this. It is going to be 8 plus 6 plus 4. This is coming out to be 18. Therefore, we can say that it is stable. Therefore, we can say that it is stable. Since it follows the 18 electron rule, therefore we can say that it is stable. I hope it is clear. Yes, PK45, you are absolutely correct. Yes. So, moving on. Now look at this question. Can anyone tell me what is this and what will be the contribution of this? Can anyone tell me the name and contribution for this? Can anyone tell me the name and contribution for this? Please write down in the chat and tell me what do you think the name and contribution for this is going to be. Okay, Anuj Chauhan says that its contribution is going to be 5. PK45 says cyclopentadienyl. Suresh says CP. Aman Sharma. It is Aman Sharma. It is not cyclopentadiene. It is cyclopentadienyl. All right. Now this is actually yes, you're absolutely correct. This is CP. See, now I'm going to tell you something important about CP. This is CP or cyclopentadienyl. Cyclopentadienyl. All right. Now its contribution here, or I can say its heptacity is going to be 5. Now someone had asked me earlier, what is heptacity? Okay, what is heptacity? So let me just tell you first what heptacity is. What heptacity is. Now heptacity here, it is defined in case of organic ligands. Heptacity is defined in case of organic ligands, and it is the number of sites on the ligand. It is the number of sites on the ligand. It is the number of sites on the ligand to which metal is directly attached. To which metal is directly attached. Okay. So heptacity is actually represented by eta raised to the power x, and this x is actually the heptacity, or it is the number of sites to which metal is directly attached on the ligand. Okay. So if I have to go back to this question, coming back to this question, how are we going to find if this is stable or not? Here, okay, one more important thing is that if there is no number of sites, there is no heptacity mentioned, then you are going to take the maximum heptacity. All right. If the heptacity is not being mentioned in the question, for example, if no eta 5 or eta 3 or eta 1, if none of this is mentioned in the question, not mentioned, if none of this is mentioned, then you will have to take the max. Then take the max heptacity. So how will we solve this question? How can we solve this question? Here in case of CP, it will be 5. Here this is molybdenum. Its group number is going to be 6. All right, its group number is going to be 6. Plus, now this here ligand metal is attached to 3 sides of the ligand. 1, 2, 3. So how much is its contribution going to be? It will be 3 plus 2 for this carbonyl plus 2 for this carbonyl. What does the total come out to be? It comes out to be 18 again. All right. It is again coming out to be 18. Therefore, I can say that this is also stable. This is also stable. I hope everyone is able to understand. All right. Now, I hope this question is clear and everyone must have understood what does heptacity mean and how can we use it in questions like these. Now, moving on to the next question. Is it clear? If everyone understood this, please let me know in the comments. Suryansh Kashyap, अनूप जी पढ़ाएंगे क्या? सूर्यांश, Anup sir is busy on the app these days. You will be informed whenever next of his lectures will come. Okay, Monica Thakur, thank you. So we will move on to the next question from here. See, now look at this question. Look at this question. Again, we have here Cp. We know that the contribution of Cp, there is no eta mentioned here. Okay, so what did I tell you? Whenever no eta is mentioned, then we are going to take the maximum contribution. Okay, in cases like these, we take the maximum contribution. So it is going to be 5 over here plus this is carbonyl, its contribution is going to be 2 plus this is chromium. Just calculate in your head what its contribution is going to be. Its group number is going to be 6 plus when this mu is given, it means this carbonyl is acting as a bridging ligand. But over here, again, its contribution is going to be 2. And since there are 2 of these, we will multiply it by 2. Plus, for rhenium, what is the group number for rhenium? For this, it is going to be 7, all right? Plus 2 plus 5. Solve it and tell me the answer. Did you understand this? Please let me know. Okay, Anuj Chauhan is asking me why. Oh God, Anuj Chauhan is asking me why 18 electron compound is stable. Anuj, I feel that you will have to take the classes for JEE and NEET for me to be able to explain you that. Please go back to the class 11, 12 chemistry and you will get the answer to that. Okay. There is something seriously wrong with the basics here if you have to ask me that why 18 electron compound is stable. I will request you to please go back and have a look at the 11, 12 chemistry. Monica, yes, bridging, mu CO means bridging. PK45 says that the answer is going to be 31. Yes, exactly. Monica also says 31. Yes. So, but ideally, its answer is coming out to be 31. But ideally, it should have come out to be 36 since there are 2 metals. All right, there are 2 metals. So it should have been actually 2 into 18 equals 36. The electrons should have come out to be 36, but this is not 36. Therefore, this is not stable. All right, it is not stable. Also, have you people liked this video yet? If you haven't done that already, please like today's video, subscribe to our channel and share it with your friends. Okay, so I hope everybody got this question. This was a different kind of question, the kind of questions that you get asked in exams. Okay. Now, moving on to the next question for today. Look at this question. Now, again, we will calculate the valence electron count here. So, calculating the valence electron count for Br. For Br, we know that its contribution is 1 plus For CO, it is 2, and since there are 4 of these, it will be 2 into 4 plus group number of chromium is 6 plus for CpH. Can someone tell me what is going to be the electron count of CpH here? Please let me know in the chat what is going to be the contribution of CpH. Monica Thakur M.K. Mahato, I am not asking you the total electron count. I am asking you for CpH. Please tell me what is going to be the contribution for CpH. I'm not talking about the total. Okay, Monica says 3. Anuj, I'm not asking the total right now. Vishnoi says 5. Okay, okay. Some are saying 3, some are saying 5. Okay, now he has come to 3. All right, all right. So let me just tell you for once. Yes, Sunil Yadav also says 3. Devasi's Barik also says 3. Yes, you're right. But I will still explain for once how is it going to be 3 for the ones who do not know. So this is CpH. Suppose first of all this is C. All right, this is C. Now it has 4 electrons. We know that C is going to have 4 electrons and one of it has been bonded with pH. Now calculate the total number of electrons on C now. Now there are 1, 2, 3, 4 and 5 electrons. All right. And for it to be stable, it should have 8 electrons. It has 5 electrons, but for it to be stable, it should have 8. So if we are going to subtract its deficiency and we will find out its deficiency, this is going to be the charge. All right. That is how we calculate the charge. All right. So you will first write down the valence electrons, then the number of electrons it got from bonding, and then the deficiency is going to be the charge on that particular species. So here the charge is coming out to be 3. Now let us solve it. It comes out to be 1 plus 8 plus 6 plus 3. So it is coming out to be 18. All right. It means it is stable. It means it is stable again. Suresh Yadav, 6 is absolutely incorrect. Please look at what I have just explained. Monica Thakur, ma'am, C has 4 valence electron. 1 is used for bond with pH, that is left 3. Monica, actually we find out by the deficiency. But this is also correct. No problems with that. You gave the correct answer. Okay. All right. I hope this was clear. There was no big deal in this. Everybody got it. Okay. Now, moving on. M.K. Mahato, if CpH2, then it's contributing 2 electrons. Yes. Yes, you are right. Then its electron contribution is going to be 2. Okay, now moving on to the next question. Now look at this question here. See, which Cp eta has been mentioned. In this case, the heptacity for Cp has been mentioned. So now we are not going to take the maximum heptacity. When it has been mentioned, when we have been given a particular heptacity in the question, then that is exactly what we will take. Here it has been given 1, so we will take that only while solving the question. Now, coming to its answer, how will we do it? So, calculating the VEC for this, eta has been given 1 for Cp, so 1 plus. For beryllium, the contribution is going to be 2. The valence electrons are 2. All right, so we will take 2. And the eta for this Cp has been given as 5. All right, it has been given as 5. So the valence electron count is coming out to be 8. Will this be stable or not? Please tell me, will this be stable or not? M.K. Mahato, I just answered your question. I just said that yes, CP2 is going to be contributing 2 electrons. I did answer your question. Monica says yes, it is stable. Ashutosh Oja says stable. Abhinash Sahu also says it is stable. Yes, stable. Yes, yes, yes. All of you are correct. It is going to be stable. Why? Why is it going to be stable? In spite of having only 8 electrons, how is it still stable? Because that is because BE belongs to S block. Okay, BE belongs to S block. Therefore, it follows the octet rule. BE belongs to S block and it follows the octet rule, and here it is absolutely satisfying the octet rule. Here it has 8 electron and therefore it is satisfying the octet rule, and therefore it is stable. Now moving on to the next question. So before I do this question, there are certain applications. Okay, there are certain applications of the 18 electron rule. So I will discuss those applications one by one, and simultaneously we will keep doing questions. So coming to the applications of 18 electron rule. Applications of 18 electron rule. Okay, so first application it helps in determining the number of unknown ligands. Okay, so it helps us in determining the number of unknown ligands. What do I mean by that? See here, as you can see this question, in this question here, we do not know the number of ppH3 that we have in this compound. What is missing here? The number of ppH3 are missing here. So how can we determine that? We can simply determine that by making use of the 18 electron rule. Yes, you're still commenting. Monica says it does not have d orbital. Yeah, basically since it belongs to the S block, therefore that is the reason. Okay, so now for determining this X, we will apply the 18 electron rule on this compound. Okay, so on applying the 18 electron rule here, we know that the group number of the metal ion here it is here it is 8. It is 8 plus the contribution of the ligand. For CO we know it is 2 into, since there are 2 of these, we are going to multiply it by 2 plus we do not know X, but we do know the contribution of ppH3, so it is going to be 2x. Okay, and plus minus charge on the sphere, since the charge on the sphere is -2, so we are going to add +2, and this will be kept equal to 18. This will be kept equal to 18. Now solving this, we will get 8 plus 4 plus 2x plus 2 equals 18. Solve for this and please tell me the answer. Solve for this and tell me what should be the answer. Anuj says 2. Abhinash Sahu says 1. Anuj, yes, correct. Monica, correct. Abhinash, you need to recheck your calculation. I think you might have made some mistake with the calculation. It is actually going to be 2. It is what? 2x equals 4. Therefore, x equals 2. So the number of ligands, PPH3 ligands here are going to be 2. All right, so this is how, with the help of 18 electron rule, we can determine the number of unknown ligands. Now moving on to the next application. All right, we will move on to the next application. Ashutosh Ojha, yes, 2. It's okay, Abhinash. Keshav says 2. Yes, you are all correct. I'm sure you've all understood how do we do these questions. Now coming to the second application, of 18 electron rule, how do we do it? Under the second application, it also helps us determine. It helps in determining the charge on the sphere. It also helps in determining what charge does the sphere hold. That also it helps us in determining. So solving this for BEC, group number of chromium, it is going to be 6 plus. For CO, the contribution is 2 into, it is going to be 2. All right, plus for PPH3, we know it is 2 since there are 2 of these, again 2. Plus for chlorine and bromine, it is 1, 1 each, plus 1, and plus Z also we will do here. Now, since here we have chromium, we are going to keep this equal to 18, only one metal. Now solve it and tell me what should be the value of Z. 6 plus 4 plus 4 plus 2 plus Z equals 18. Tell me the value for Z, please. Okay, Z they're saying -2, -2. All of you are saying Z is -2. All the ones who are saying that Z is -2 are wrong. Let me first clarify. See, okay, yeah, you have okay, maybe you have given the answer finally inverting it. I think you have already converted it and changed the sign and you're telling me the final value of charge. Yes. Okay, then you are right. See, you are telling me the final value of charge after changing the sign, then that is going to be -2, yes. So now Z is coming out to be 2 from here, but since we know that we invert the sign of the charge, then invert sign of the charge. After inverting sign, it is going to be 2. All right. So the overall charge on the sphere is going to come out to be -2. Yes. Anuj Chauhan, you are absolutely correct. Yes, you are all correct. The ones who are saying because we changed the sign of the charge on the sphere, that is how we are going to get -2 as the charge in this question. Okay, moving on to the next question. I hope it is pretty clear to everyone. Everybody is answering really well. Very good, all of you. See, now this question, have a look at this question. Again, we have been given CP, calculating the valence electron count. Again, we have not been given any heptacity for CP here, so we will take the maximum contribution. 5 plus. The group number of Mn is going to be 7 plus CO. We know that the contribution of CO is 2. We do not know the number, so we will multiply it by X. But since, can you see this 2 outside the bracket? Therefore, this whole thing will be multiplied. This whole thing will be multiplied by 2. Okay, this entire thing is going to be multiplied by 2 plus, since it says that it contains two metal-metal bonds, since it says it contains two metal-metal bonds, can someone tell me what is going to be the contribution of the metal-metal bonds? Can someone tell me what will be the contribution of the metal-metal bonds here? Please write down in the chat. I'm waiting for your response. Monica, don't tell me the value of X. We will come to that. But right now, can you tell me what will be the contribution of metal-metal bonds here? Anuj Chauhan, yes, you are right. You are right. M.K. Mahato, oh, you have literally solved the entire question in the comments. Okay, that's all right. Yes, you are right. You're right. See, so since there are two metal-metal bonds and each bond will have 2 electrons, so its contribution is going to come out like this. Now we will keep it equal to, since we know that there are going to be 2 Mn because of this 2, so we will take it 2 into 18. Okay, now we will solve for X. Now we will solve for X. 12 plus 2X into 2 plus 4 equals 36. So it is going to be 24 plus 4X equals 32. All right. 4X equals, it's going to be 8 and X is going to come out to be 2. Okay. That is how we are going to do this question. I hope everybody got it. So it is very important for you to include the contribution of the metal-metal bonds. It is very important to include the contribution of metal-metal bond, or your question is going to get incorrect. Be very careful. It may or may not be mentioned in the question that the number of metal-metal bonds in this compound is this. It is very much possible that sometimes you might have to find it out on your own. So in cases like that, just remember to include always the contribution of the metal-metal bond. Ashutosh Ojha, ma'am, please revise this question. Okay, I will explain this question one more time. See, let me change the color of the pen and I will mark and tell you. Okay, see, the contribution, see Ashutosh. See, this is Cp, its contribution is 5, all right? We have not been given any value of 𝐓𝐴, so we will take the maximum contribution. All right, we will take the maximum contribution here. Now this is Mn. We will take the group number of the metal, which is 7. Now CO has contribution 2. All right, and we do not know its number, so we will take 2x. We took 2x. Since this bracket, this 2 is given outside the bracket, then we will multiply this entire bracket by 2. Also, the question says that there are 2 metal-metal bonds. So each metal bond will have 2 electrons. All right. Per metal bond, there will be 2 electrons. So we will also have to add those electrons for 2 metals. Okay. One metal-metal bond has 2 electrons. So when there are 2 metal bonds, we will multiply it by 2 electrons. That is per metal bond electrons, and it will be equals to 2 into 18. That is 36 because there are 2 Mn. ये ब्रैकेट के बाहर 2 दिख रहा है ना आपको, इसका मतलब 2 मैंगनीज है, तो 2 मैंगनीज हो गए तो मतलब 2 मेटल्स हो गए. जब 2 मेटल्स हो गए, it means that the total will should be equal to 36. That's how we solved it, and we determined the value of X, and this is going to be the number of carbonyls. I hope it is pretty clear now. It's okay, Ashutosh. M.K. Mahato, I want everybody to be able to understand. It's okay, we will move to the next question now. So moving on to the next question. See, now look at this question over here. In this question, Okay, I'm giving you 30 seconds. Solve this question and tell me the answer in the chat. I'm giving you 30 seconds to solve this question. Quickly solve it and let me know what should be the answer in the chat. Quickly solve this. I have explained to you a few questions based on this. I hope it should be solvable now. Please solve this question and let me know the answer in the chat. I am waiting for your response. Please solve and tell me what should be the answer. Okay, M.K. Mahato is saying -3. I'm going to wait for a few more seconds for others to solve. Then I will explain how to do this question. Okay. Okay, now, yes, MK, you are correct. Let's see how to do this question. Calculating the valence electron count, we know that the contribution of CO is 2. So we will multiply it by 3, which has been given outside the bracket, plus the group number of nickel is 10, plus the group number of cobalt is 9, plus the contribution of this is again going to be 2 into 3. What is very important to note here is that the most important thing to note here is that this is also a metal-metal bond. Since in this question you have not been given that it has any metal-metal bonds, this is something for you to figure out yourself. Such questions are going to come in the exam and you're going to make them wrong because you're going to miss out on the metal-metal bond, which is the most important thing in this question. So plus 2, which is for the metal-metal bond, plus Z. Since there are two metals, okay, since there are two metals, so I'm going to keep it equal to 36. I'm going to keep it equal to 36. Now for solving this, we get plus, from here we get 19 plus 6 plus 2 plus Z equals 36. All right, solving this, we get Z equals 36 minus of. All right, so Z is coming out to be 3. But since I have already told you that in case of the charge on the sphere, we invert the sign. So again, we are going to invert the sign. We're going to invert sign. Therefore, charge is coming out to be 3. Positive ka 3. This is positive ka 3 is going to be the charge. Yes, MK, you're correct. Atri Hazra, also correct. Monica, very good, very good. Keshav, right. Just remember that oh sorry, I forgot to write the minus here. -3, yes. Yes, MK, 2 electron contribute by metal bond between Ni and CO. Yes, right. Ashutosh, also correct. I hope everybody understood this. We are done with this question now. Okay, now have a look at this question. Let's do this. This is also very easy. Another very easy question. We have just done this. So here it is going to be. So here it's going to be 5 into 3 for CP. Okay, plus group number of nickel is 10 and into 3 since there are 3 of those, plus we know that for mu3 we have 2 into 2 since its contribution is 2, plus Z, plus since it says it has 3 metal bonds, so therefore 3 into 2. Okay, and since there are 3 and I, so this time we will take actually 3 into 18. Please solve this and tell me the value for Z. Solve it and tell me the value for Z. What should be the value for Z? Please write down in the chat. Okay. So here upon solving this, we will get 15 plus 30 plus 4 plus Z plus 6 equals 54. Solving this, we will get Z equals 54 minus of, this will become 55. Therefore, Z is coming out to be -1. All right. And charge is going to be 1. Okay. Okay, I think everybody got it. M.K. Mahato, yes, correct. Abhinash, Monica, Somnath, Keshav, Anuj, Ashutosh, Mosmrita. Yes, 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 you are all correct. Everybody got it. Monica says, ma'am, previous question में calculation में कुछ problem है, I think. क्या problem है previous question में? Let me go back to it. Please tell me the problem. What is the problem? Let me check once again. This is 3 2s are 6 plus 10 plus 9 plus again 3 2s are 6. And this 2 is for the metal bond plus Z equals 36. What is wrong here? 6 plus 19 plus 6 plus 2 plus Z equals 36. 36 minus 25, 31. Absolutely correct तो है Monica. Absolutely correct hai Monica. I don't think there is any problem here. You need to check your calculation again. Ravi Prakash Verma plus 2. Yes, yes, yes. You are right. Acha. Monica, after the class is over, please you quickly check your calculation once again, because my calculation is absolutely correct. I think you have taken Z as 2 and added it. That is Z and not 2. Now, okay, we do not have much time. I have to just quickly complete this one more question and then we will end the class. So, the next application is, I don't remember the number, but the next application is, it helps in determining the metal ion. Okay, 18 electron rule also helps in determining the metal ion. M.K. Mahato, ma'am, please first give us solve, then you answer with explanation. M.K., do you mean that I should let you solve first? Okay, quickly do it because the class is only till 2. I'm going to end the class very, very soon. Quickly, very fast, solve this question. Try, give it a try. Quickly tell me the answer, please. Otherwise, I will have to solve it. Quickly solve and tell me what you think should be the answer, then I will tell you. Please do it fast. Also, this is not really a question, this is just an explanation. I'm telling you the application. Okay, so let me please tell you the application, then it will become very easy for you to solve it. Oh wow, all of you have done it. M.K. Mahato says cobalt, Abhinash cobalt, Mosmrita, Monica, Ravi. Ashutosh, yes, I am solving it. Anuj. Abhinash Sahu, I don't know what you mean by VE of metal 9. I don't know what does that mean. Okay, let me solve this question. See, you know this is CP, this is cyclopentadienyl, and we know that its contribution is what? 5. Its contribution is 5. This is what we have to determine. We do not know what this metal is, right? So this is what we have to determine. So we are going to take it to be X, and this is again has a contribution 5. So what is the total coming out to be? The total is coming out to be 10 plus X. Oh, sorry. Have I made a mistake? Okay, it is actually 4, right? This is obviously 4 because it is attached to 4 centers. The metal is attached to 4 centers of the ligand. All right. So this is going to be 9 plus X. All right. And this should be equals to 18 as per the 18 electron rule. So what is going to be the value of X? The value of X is going to be 9. All right. This is the value for X and it is going to be 9. Now, from this, we know that it has to be a metal of group 9. One important thing to note over here is if you do not get an answer in the options that belongs, if you do not get an element in the options which belongs to group 9, what are you going to do then? अगर suppose ऐसा option आ जाए जिसमें group 9 हो ही ना, चारों options में group 9 का कोई metal नहीं है, then you will be stuck. What are you going to do in that case? Do you get my concern? Okay. So in that case, this is what you will do. Suppose this is group 9, group 10, and group 8. This could belong to the 𝐂𝐨𝐵𝐿 family, right? 𝐂𝐨𝐵𝐿. So we will take either a group before it or a group after it. I will tell you how. So if it is a metal from group 8 with a negative sign, then that can also be the answer. And if it is a metal from group 10 with a positive sign, then that can also be the answer. You get it? Group 8 के ऊपर negative charge होगा तो वो भी answer consider हो सकता है, और group 10 के ऊपर में positive charge होगा तो वो भी answer consider हो सकता है. So that is how we do questions like these. Similarly, it is not just for 3D series. This will also apply to 4D and the 5D series. I hope all of you understood this. So these were the questions. These are some important questions from Organometallics because you had asked me to discuss some questions based on 18 electron rules when I did the previous year questions in lecture 1. I hope all of you enjoyed today's session. All right, and please subscribe to our channel if you haven't done that already. Like this video. I hope you really enjoyed today's session. I tried to came up with interesting questions today, and these are the kind of questions that actually show up in your exams. Share this video with your friends and also hit that bell icon so that every time we upload a new video, we come up with a new lecture on a new topic, you will be immediately notified and you can join the lecture and solve the questions with us. Thank you so much for joining in. All of you, please stay safe and keep watching Chem Academy. Bye bye, everyone.